Hello and good day to the lecturers. I am NAIR from Group 3 along with my group mates, which is ASWIN, WAFIY and HAZIM ZAFRI. Today we are going to present our project, which is the electrical project, and we will get into the engineering blueprint. As you can see, our electric car is a mini vehicle scale 1 to 32 that uses AA batteries without a remote control. And the chassis is the main part of this car because it holds everything in place, which goes to the gears, the motors, bumpers, tires, rollers, and so on. So our frame is actually just one part that has multiple locks, so that when we put in the motor in place, we put the gears in place, it will click and it will lock the other parts in place. And the wheel distance of our car from the front wheels to the rear wheels is 72 millimeters or 7.2 centimeters, while the wheel distance from the left wheel to the right wheel is 62 millimeters or 6.2 centimeters, and our car has a ground clearance of 10 millimeters or 1 centimeter and weighs around 64 grams, which is ideal in our part for ground clearance because in most of our testing of the car has never faced where it's stuck due to the terrain we have put it through. And that's all for our engineering blueprint.
Hello, I'm Ashwin and I'll be talking about the safety and experiment accuracy procedures that we use in the process of testing our car model. First of all, we follow battery safety guidelines. Next, we also monitor the motor to prevent overheating so that it doesn't go bad. We also disconnect batteries when making adjustments or recording data so that the battery does not lose power. We also repeat the experiments with different conditions to ensure consistency. Last but not least, we also take averages to improve the accuracy of speed measurements. Next, I'll be explaining the procedures for the electrical measurements that we implement in the process of testing our model. For the experiment, we use, of course, a 3-volt DC motor. Next, we also got a multimeter, and we use 2 AA batteries and 2 tester cables. Firstly, we put the cables in parallel to the open circuit to measure the voltage, the circuit voltage of our car model. We set our multimeter setting to 10 volt DC, and as a result we got the circuit voltage that we will record. Nextly, we will arrange the cable in series to the open circuit. This is to record the circuit current, and nextly we will set the multimeter setting to 10 ampere DC, and as a result we will get the circuit current that we will record. We will repeat steps to increase readings accuracy, of course. And nextly, I'll be talking about the materials and procedure that is used in our motor performance testing. The materials, of course, we have our 3-volt DC motor and the 2 AA batteries that we have used from the car model itself. And next we have the multimeter, we have a stopwatch, and we have varying loads. And we also use our data recording device like rulers and such on. Firstly, we connect the 3-volt DC motor to the AA batteries in series. Ensure all the connections are secure. Nextly, we will start the motor with no external load attached, and we will visually observe the rotation speed and estimate the RPM. We do this by marking a point on the motor shaft and counting the number of rotations within a specified time frame. And how we do this is that we use the slow-mo function on our cameras to see how much RPM that our motor has. Nextly, we will attach the load to the motor, and we will record the changes in speed in the motor's performance under the load. And as a result, we will also measure the current drawn by the motor using the multimeter, of course, and we will calculate the electrical power input, and as a result As a result, we will also get the changes in power, and we can definitely calculate the efficiency of the motor. Last but not least, we will analyze the attained data to understand the motor speed characteristics, and the variations in speed with and without load will be noted.
Hello, my name is WAFIY. For the thermal management process, we use the equipment infrared surface thermometer. The procedures are: for the first, record initial temperature of battery. Next, run car for 30 seconds. After that, record final temperature. And lastly, repeat steps 1 until 3 for the motor. Here is a recorded motor performance test between torque and speed. For the left side, we got a 0.27 and negative 0.29. And at the right side, we got the horizontal graph between torque and speed. For the motor performance under load, we got a voltage 1.7 voltage and the current 0.3 ampere, and for the power 0.51 watt, and efficiency we calculate and get 48%. For the electrical measurements, for the circuit resistance we got 3.7 ohm, and the voltage we use the formula from at the given, and we substitute the certain numbers, and we got 1.705 voltage.
Hello, my name is HAZIM, and I would like to continue our presentation for design detail discussion. And mainly for design detail discussion, would like to discuss more about thermal management. Quarterly temperature of battery, we have measured that is 26.7 degrees Celsius, and for motors is above 60 degrees Celsius. Importantly, in our electric vehicles, we would like to promote our discussion on importance of thermal management, and more importantly, potential cooling solutions. From the discussion, we found out that we need to improve more our battery performance and its longevity. Others are improving its efficiency on charging, and moreover, its liquid and air cooling. In electric vehicles, I would like to emphasize that there is the concept of electromagnetic interference, EMI, which refers to disturbance caused by any other electromagnetic fields, and will disturb or interferes with our electronic vehicles. Thus, this unwanted electromagnetic emission will affect our performance on the electric vehicles because of the electronic system in our vehicles. In other words, the electric vehicle cannot properly operate because due to the EMI. As conclusion, electric motors convert electric energy to mechanical energy from the interaction of motor magnetic field, and provide force to supply torque in the motor shaft or on the motor shaft. And from based on our torque versus speed graph, we gain that we have 16,500 revolution per minute for our electric vehicles, which is 48% efficiency of torque, or in other words, it is a stable value for our motor performance. I think that's all from our group. Thank you very much.
Okay lah.